stress condition and a plane strain condition. The plane stress condition is a one condition in which stress acting in one plane is zero. Okay, stress conditions. Okay, in which stresses acting in one plane is zero. For example, here stress conditions here the normal stress sigma z, shearing stress that tau xz and tau yz that all are acting in the z plane is zero. Okay, if we satisfy these conditions, then we will call as a plane stress condition. Okay, basically here you'll observe that we have non-zero stress component in one plane. Okay, in one plane only. Okay, this basically this plane stress condition is applicable for thin plate like structure where we apply the load in a plane. Okay, we have one plate, very thin plate, and we are applying the load in a plane only. Okay, for example, this is our x-axis, this is our y-axis, and this is our z-axis. Okay, so here we are applying the load in one plane, xy plane only. This is x, this is y, so we are applying the load in the xy plane. So if we apply the load in xy plane and that structure and the structure is very thin. Okay, so we have very smaller thickness, that z is very thin. Okay, we have very small thickness. In that case, what happened, our stress condition that will develop in the material will be significantly higher in that xy plane only. So we'll have significantly higher stress sigma x, sigma y, and the tau xy. Okay, and the stress component related to the z direction will be zero. Okay, so this condition is basically we are saying our plane stress condition. Okay, so plane stress conditions basically applicable for a plate-like structure where one direction is very thin, and loading condition are also applied in that plane only. Okay, if the loading is acting in the z direction, okay, in that case there will be bending stress. Okay, so that plane stress condition is not applicable. Okay, so plane stress condition is applicable for thin plate. Okay, and it is a state of stress of a body in which stress corresponding to one principal plane is zero. Okay, for here we are considering z plane. Okay, the stress component acting in the z plane is zero. It can be other plane also. And how we basically orient the structure here, basically we have oriented that plate in xy plane. So here z plane we are considering as the outer plane. Okay, and we are considering all the stress conditions acting in the z plane is zero. Okay, so we'll see how we can write these things mathematically. Okay, so before going to that, we'll discuss how stress and strain is correlated. We know that as per Hooke's law, the stress is proportional to strain, and from that stress we can write that E into that strain condition, E into epsilon. Okay, now these conditions we used to write when you have a body and we have force acting in one direction. Okay, now if you have force, okay, if you have body, okay, if you have 3D body and if we have 3D body and we are applying the load in all the three directions, in that case Poisson in that case, okay, we have body and we are applying the force in all three directions. Okay, in that case our strain conditions can be written in this way. Okay, the strain along x that is equal to stress by your E value, Young modulus, minus that stress in the other direction by E into the Poisson value, that your mu, and stress applying in the z direction by E into the mu. Okay, so similarly we also can write strain conditions. Okay, and this is basic relation for the sharing stress in the yz plane, in the xz plane, and then xy plane. Okay, now if you write this equation in a matrix form, we can write in this way. Okay, so here we can see this first line. Okay, the first row is corresponding to the first equation, second row it corresponds to the second equation, and third row, okay, is corresponding to third equation, and this one, the sharing stress is corresponding to this one. Okay, the fifth one equation is corresponding to this equation, and sixth row is corresponding to this equation. Okay, So here you can see that shearing stress term is coming on the in the diagonal term. Okay. So now we come to our plane stress condition. This condition is basically in general where we are applying the load in all three directions and then how strain and the stress is correlated. Okay. Now if you come to the plane stress conditions, already have discussed that plane stress condition is that condition where the stress acting in that one particular plane here, z plane, is zero. Okay, stress in the z plane is zero. So we're putting this value zero. Okay, if you put that value zero, then our equation will be like this. Okay, equation will be like this where we can eliminate the z term and we can write like that. Okay, now if we see, since this value and this value is zero, correspondingly that strain here and here, this also will be zero. Okay, now here you can see that the strain along the z, okay, strain in the z direction, okay, normal strain is not zero. Due to the Poisson effect, there will be some strain. Okay, so here you just keep one thing in your mind that in a plane stress condition, we have the stress acting in that plane x in the xy plane. Okay, stress acting in one plane. So here strain in xx, strain yy, and we have shearing stress. Along with that, we'll have a strain in the z direction. Okay, so all the strain in the z direction is not zero. One strain condition will be there, which is basically acting in that direction. Okay, in the z direction. Okay, will be non-zero. Okay, so this is one plane stress condition. Okay, now if we write that same thing in a matrix form, we can write that the relationship in this way that strain along xx, normal strain along yy, and the shearing strain in the xy plane that can be written in this way 1 by e in bracket 1 minus nu third and here 2 into 1 plus nu, and this side will be our shearing stress. Okay, and there will be our one normal strain, okay, in the z direction, that value will be there. So in the plane stress condition, along with that shearing, along with that in plane strain, will have out of plane strain will be there. Okay, now again if you want to write this equation in terms of stress, then we can write in this way the sigma x, sigma yy, tau xy, that is actually e by 1 plus nu in bracket 1 minus nu 1 nu 1 1 minus nu by 2 here. Okay, along with that there will be our along with that we will be our strain that is acting out of the plane. Okay, so this is basically plane stress conditions where we have stress condition that is acting in a plane. Along with that, there will be one strain condition which is acting out of the plane. Okay, now we'll discuss that plane strain condition. Okay, so already we have discussed plane stress, that is basically applicable for thin plane, and load are also applied in a plane. Okay, now if you consider plane strain condition deals with the situation where we have one dimension which is comparatively very large in the other two directions. For example, a dam or retaining wall. Okay, so if you consider the dam is look like this, and here you can see that one direction of the dam is very large in comparison to our other two directions. For example, this is our x and this is your y and this is z. Here you can see z direction is comparatively very large. Okay, this is also true for our retaining wall. And one more thing, you'll also observe that force acting in that dam, force acting in the dam due to the water, you will see that is acting in the plane, okay, in that xy plane, and that is basically distributed along the length, okay, larger length, okay, and basically that is perpendicular to the larger length. Okay, so this condition is basically, we say that is your plane strain condition where we have one particular dimension is significantly higher than the other two direction, and forces also applied in that xy plane, and that is vary or distributed in the larger direction. Okay, so what happened in this direction? The strain that is generating along the larger direction is very smaller, and we consider that value at zero. Okay, that condition which we call our plane strain condition. Okay, so in the plane strain condition, our strain acting in one plane is 0. Okay, so here again this equation is our known equation, where this is for our 3D body, where we have force acting in all the three directions, and we can write like this. And if you write that is same, because in terms of stress we can write in this way. Okay, now what we'll do, we'll put our plane strain conditions, where in the larger direction, that is our z direction, okay, the strain is very small, okay, and we consider that value is 0. If you put that value 0, then what we'll get this equation. We can write the plane strain condition in this way, that E by 1 plus nu, 1 minus nu, okay, in bracket 1 minus nu, 1 minus nu, and then here 1 minus 2 nu. Okay, now here again you just see, when you put this value 0, okay, that sigma zz stress will not be 0. Okay, so this is very similar nature of our plane stress condition. In a plane strain condition, okay, our strain value that will be 0. Okay, but that one strain, that our principal strain, one principal strain, that in the z direction will not be 0. There will be some value here. Okay, so basically in some interview, many faces this question, that in the plane stress condition whether there will be a strain in the other direction or not, or in case of plane strain condition whether there will be stress in other direction or not. Okay, so the answer is yes. In a plane stress conditions, we will have a strain in other direction, principal direction, and in case of plane strain condition, we will have stress in that other principal direction. Okay, so here if we summarize, okay, you will see that plane stress conditions, okay, in that conditions we have stress in that xy stress in one plane. Okay, in a plane stress condition we have a stress in that one plane, sigma x, sigma y, tau xy. Along with that strain in that, along with that one normal strain, one strain in one principal direction, along with that strain in other principal direction. Okay, in the plane stress condition we have a stress in that xy plane, one plane, along with that strain in the other principal direction. Similarly, in the plane strain condition, we will have a strain in that one plane, okay, along with that stress in other principal direction. Okay, so this is the basically plane stress condition and the plane strain conditions. I hope you got some idea. Thank you.